welcome to all friends, family, and partners. Tonight, you will witness the moment in which we review what we have been working on so hard for the last 6 months. We'll start in a few minutes, so hold on tight and please enjoy the night.
2022 is the year where we, the TU Delft Hydromotion team, will build a hydrogen-powered boat to become world champions in the open sea class of Monaco. Welcome to our design presentation, everyone. Thank you all for joining us. During this presentation, we will show you what we have been working on for the last couple of months and finally reveal the design of our boat. My name is Sophie van Toff and I'm the team manager of this year's team. Today, we want to take you on a mission with us. A mission to a sustainable future. First, I want to take you back 22 years ago to Arnhem, where I was born. As a kid, I loved playing outdoors and enjoyed growing up in a city filled with nature. But besides being the most beautiful city in the Netherlands, of course, there's something special about Arnhem that intrigued me ever since I learned it in high school. Did you know that Arnhem is one of the few places in the Netherlands that lies above mean sea level? Let's take a look at this map together. This map shows the Netherlands without flood protection. As you can see, more than a quarter of the Netherlands would be below sea level. For example, the place where I'm standing right now, the TU Delft Aula, would be completely flooded without the protective water management of the Netherlands. Think about it for yourself. Would you be able to live where you live right now without flood protection? However, this picture is changing as the world around us is changing. Due to climate change, the sea level in the Netherlands is estimated to rise 1.2 meters before 2100 compared to the beginning of the century. If the ice sheets in Greenland and Antarctica continue melting, this number could even go up to 2 meters. The impact of the rise in sea level is enormous. If no additional measures would be taken, this would be the Netherlands in 2100. Even if this still feels far away, the consequences of climate change are already visible in our daily lives right now. Who recognizes this picture? This was Limburg last July. Extreme rainfall led to flooding in large parts of Limburg, Germany and Belgium, causing billions in damage and personal losses. More than 200,000 people had to evacuate and a lot of people lost their homes. These intense rainstorms are becoming more likely to occur in Europe as a result of global warming. So I think we can all agree that we can no longer ignore global warming. So the world around us is changing and we're all part of this change. But this also means we are all part of the solution. Every choice we make has an influence on the world of today, and it's our responsibility to make the right choices to positively contribute to the world of tomorrow. Think about it for yourself. What choices are you making to contribute to a sustainable world?
So being from the island of Curacao, I've seen firsthand what happens to a formerly beautiful ocean when it's not taken care of. It's our job to take care of nature. As such, I joined the Hydromotion team to spearhead the effort in creating, realizing, and promoting the adoption of sustainable maritime technology.
We are aware of the need for change and we learned theory during our studies. But now we actually have the chance to contribute to a more sustainable future.
I wanted to join this awesome project to gain experience with hydrogen. I believe hydrogen will play a vital role as an energy carrier in the future, both in the electricity grid and in the transportation sector. By getting familiar with it now, we can help realizing this potential.
I believe that we can make this change if we keep working together. I joined this team to make my contribution for a more sustainable world. Because together, we can make it happen.
We are the TU Delft Hydromotion team, a group of 24 driven students from 11 different study backgrounds. We put our studies aside for an entire year to work towards the same goal. We want to accelerate the implementation of sustainable energy technologies. We do this by showing what's possible when you combine the strengths of our team members with the experience of alumni and the knowledge of industry experts. Together, we design, build, test and race a hydrogen-powered boat in just 1 year. By demonstrating what we can achieve with the right mindset in just 1 year, we want to accelerate innovation in the maritime industry. To reach this goal of a greener maritime industry, we all have to work together. Together with our partners, we take the next step towards a sustainable world.
Our current society isn't sustainable for decades. So we have to take some action.
As we probably all know, is that 2 to 3% of the emissions on global scale is actually caused by the maritime sector.
The industry faces a lot of challenges, and because they grow in towards 2050, they will grow with 100%. And on the other hand, we need to make the shift to sustainability and a more sustainable way of transportation.
And that's why something needs to happen to make sure that the way we receive our goods from all over the world is done in the most energy efficient way.
On the one hand, we have growth, and on the other hand, we have innovation. And we need to completely renew the fleet within, let's say, 30 years. That's an extreme challenge for all of us.
Yeah, we speak to a lot of customers, ship owners, and they all are facing the same question these days. Going forward, they have to abate on their carbon emission, and they have to choose one of the alternatives that are currently available.
It can be either electricity, hydrogen, methanol, and we have to be prepared for our vessels to adopt this technology in the vessels.
And the collaboration with the Hydromotion team is a very important one, because we want to explore all the possibilities, all the different ways of making the big step towards a energy neutral operation, energy neutral vessels. We need to know every little opportunity that there is out there. And this is just one example of a great team that is doing exciting stuff, and we want to be at the forefront of that development.
It inspires me and us as a company that the team managed to build this, to do this, and to not only take a design and perfect it, but to just develop the design and just go for it. And especially in this energy transition where we're in, these are the projects we need.
This team brings together a group of companies sponsoring and supporting this initiative, and our ultimate goal will be, of course, to together with these companies bring this initiative towards a full-scale business model whereby a ship on hydrogen will be developed, and we're happy to support these initiatives.
There are huge ambitions set for 2030 by the IMO, International Maritime Organization, part of UN, to reduce 40% of the emissions by 2030 versus 2008. And we support this ambition, and we believe it's important and significant for society, for all of us to contribute.
This team shows that within 1 year they can change a lot of things. So that's for us also the challenge to embrace.
For us it's very important that we really work together as industry, but also the universities.
I believe that through the unique collaboration that the Hydromotion team brings, all its different partners working all together to make this change, I believe it's the only way to move forward, and especially to stay the course, keep on doing it together year on year on year. That is the way we can make the change.
Together with our partners, we want to have a positive impact on the maritime industry. We want to inspire everyone, from individuals to big industry leaders, to accelerate the implementation of sustainable energy technologies and work towards a sustainable future. However, when it comes to energy transition, there is no silver bullet. Different applications require different creative solutions. Just like you do not use the same soap for washing your hair as doing your dishes, using the same energy source for powering an airplane as for charging your phone would not be optimal. So why do we start with the maritime industry? The maritime industry plays a big role in global warming. Did you know that shipping is responsible for almost 2% of global CO2 emissions? This may not sound as much, but to put this in perspective, if you would compare this to emissions per country, the maritime sector would emit more CO2 than France and the United Kingdom combined. So why do we still use transport by sea? Well, everyone is dependent on shipping in their daily lives. Take a look around you. The coffee you are drinking, the clothes you are wearing, and the screen on which you are watching this presentation right now most likely arrived by ship. It may surprise you, but 9 out of 10 products are transported by sea. This is because shipping is one of the most efficient modes of transport. So, we can conclude that the shipping industry is massive, which means there's a massive opportunity to become more sustainable. To meet the Paris Agreement and to keep temperatures from exceeding 1.5 degrees, we have to lower our emissions. That's why, in 2018, the International Maritime Organization agreed to reduce greenhouse gas emissions from shipping by 50% in 2050, compared to 2008. So, we are now in 2022. How are we currently doing in the shipping sector? If we take a look at the latest tracking report of the International Energy Agency, or IEA, we see this. We are definitely not on track, and this needs to change. That's why we, the TU Delft Hydromotion team, want to take initiative to accelerate this change. We want to accelerate the implementation of sustainable energy technologies. To become more sustainable, we have to keep our eyes open and explore green alternatives to oil and gas. Luckily, we already know quite a few, but to make a real change, we have to start using them. This is what we want to see. A world where we are no longer dependent on oil and gas, but can rely on the use of sustainable energy technologies. One option for an alternative energy source is hydrogen. We believe that hydrogen has the potential to contribute to a green maritime industry. So why do we use hydrogen in our boat? Well, let's start with the fact that hydrogen can be completely sustainable. Producing hydrogen, storing hydrogen, and using hydrogen can all be done with zero waste. On top of that, hydrogen has a high energy density. This means that you can store a lot of energy in a relatively low amount of mass. To show the true power of hydrogen, we will compete in the Monaco Energy Boat Challenge to become world champions in the open sea class. To win this race, we have designed our boat to excel in speed, endurance, and maneuverability. So, who is ready to see the design of the 2022 Hydromotion team? The boat where everything comes together. It is finally time for us to proudly present to you our design of the hydrogen-powered boat.
What a sight to behold. We can't wait to see it fly in Monaco. Thanks to Sophie for explaining the potential of hydrogen to us. But before we can show this potential, we have to put it to use first. And how we want to do that is what we will explain now. So, next to me stands Emil Kraaij, our current team's project manager.
And with me is Per Kaller, our chief electronics. Together we will be presenting the technical aspects of our boat. As Sophie just explained, with this boat we want to participate in the Monaco Energy Boat Challenge and win its open sea class. This class consists of 3 challenges: a maneuverability challenge, a speed race, and an endurance race. As if it isn't difficult enough to build a boat that is optimized for all 3 of these events, the rules state that all competing vessels need to be propelled using a sustainable energy source. Last year's team shifted their focus from using solar power to propel their vehicle to using hydrogen. They took a hull originally designed as part of a solar boat and refitted it to become a hydrogen-powered boat. This year we will be doing something completely different. We will be creating a boat entirely around this purpose of using hydrogen, and a good-looking one that is. We are building our very first seaworthy monohull. So, let's explain you how we want to do this. If you want to build a boat that is propelled using a sustainable energy source, it's a good idea to start looking at how you want to store this source. So, Pierre, why don't you elaborate on how we store our hydrogen?
Of course, because that's where it all starts. Now, as Sophie explained before, hydrogen has a relatively high energy density compared to other sustainable options. But we still have to sail for 6 hours in Monaco, and this takes a lot of energy. And next to that, last year's team had an 8-kilogram hydrogen tank. But we want to take it to another level. We want to sail faster and further. So what we did is we took their tank and we added another one on top of that. This means that we now have 16 kilograms of hydrogen aboard. And this probably doesn't say much to you, so let's compare. 16 kilograms of hydrogen equals approximately 530 kilowatt hours. Now, this is more than 5 fully charged Teslas combined. And with this amount of energy, we should be able to sail a one-way trip from Amsterdam to London.
I'm amazed. That's an astonishing amount of energy. Taking aboard with us the energy equivalent of 5 fully charged Teslas will definitely give us an edge in the endurance event. But before we can talk about the other two events, let's guide you through the rest of our boat works. Let's get technical for a minute. So Pierre just talked about our energy carrier, hydrogen. Well, we can't just pump it into our motor. We need to convert it into electricity first. The beating heart of our boat is our fuel cell. This device converts hydrogen into electricity. The hydrogen in both tanks is stored at 350 bars, which is equivalent to the pressure you would feel when 2 elephants would be standing on the palm of your hand. Effectively, this means we can take a lot of hydrogen with us in a very compact space. Now, before the hydrogen can be fit into the fuel cell, it needs to be brought to a lower pressure, at around 12 bars. After this, it is taken through a whole system of components, called the balance of plant. Finally, it's fed into the fuel cell. But for the fuel cell to convert this hydrogen into electricity, it needs to let it react with oxygen. And for that, we have an air system. An air intake breathes in air and feeds it to the airbox. This airbox contains filters which can filter out all of the ions that can be found in the sea breeze of Monaco. Ions are small little charged particles which can be found in seawater. After passing through this airbox, the air is taken to a compressor, which again ensures that we can take a lot of oxygen in a very compact space. Lastly, both the temperature and humidity of the airstream are closely monitored and regulated, so we know exactly how much oxygen and hydrogen we pump into our fuel cell. Now, this was already a quite technical explanation, but now we already know what happens to both the hydrogen and oxygen supply. We can take a deep dive and see what happens inside our fuel cell.
Right, because when we open up our fuel cell, we will see 2 sides in essence. One is called the anode, which is where the hydrogen enters the fuel cell, and one is called the cathode, which is where the oxygen enters the fuel cell. Now, this is already very much like a battery, which also has an anode and a cathode, but the main difference here is that we use this hydrogen and oxygen inside. Now, this anode and cathode, they cannot be together, so we have to split them up. And in between, we place an electrolyte, just very much like a battery again, but our electrolyte has something special. Our electrolyte is called a proton exchange membrane, and what makes it so special is that it only lets through hydrogen, and we use this to our advantage. At the anode, the hydrogen molecules are now split up into atoms. Atoms are the smallest building blocks of everything around us. So we now have electrons and hydrogen protons. And these hydrogen protons are now charged, and hence we call them ions, just like Emil explained before. Now these hydrogen ions, because they are now charged, they don't want to be at the anode anymore, so they are going to the cathode. And like I explained before, they are able to move through the electrolyte. So they do. But the electrons, they also want to be at the cathode. But they cannot move through this electrolyte. So what they will do instead is they will move through an external circuit. But this is not just any ordinary circuit. This is the electrical system of our boat. And when these electrons travel through this external circuit, they create a direct current. And they can then, for example, charge our batteries or power our motor. This is perfect. But there's just one more thing. Because we now use the hydrogen to power our boat, but we still have hydrogen and electrons left at the cathode. But what do we do with this? And that is where the oxygen comes in. We now let the oxygen combine with the hydrogen and the electrons and create H2O, or water. So we powered our boat and created water. Now, in short, hydrogen plus oxygen equals electricity, bit of heat, and water. Nothing extra is needed, no additional byproducts are created, but most importantly, we emit no greenhouse gases. So to power our boat and to power any hydrogen-powered boat actually, we emit only water. And this is what makes hydrogen such a sustainable option as a fuel. Well, now we touched upon the source of our power, but what do we do with it?
Well, we take it through another system of components. Our boat is becoming a very complex thing, isn't it? This system of components ensures our boat works in an optimal way, and is similar to one that can be found in any other electric vehicle, containing a converter, a buffer, a cockpit, an inverter, and an electric motor. So we finally arrived from our hydrogen to our fuel cell, to our electricity, to our motor. Now we can talk about the speed event. To fully utilize the power of our fuel cell, this year we opted to use a 68 kilowatt electric motor, more powerful than we've ever put in one of our boats. Down from our motor, all the way through our rear strut, we have a driveline, taking us to a custom-made propeller. This custom-made propeller ensures that the boat acts in the way we want it to, at a variety of cruising speeds. This configuration allows us to reach speeds of up to 27 knots, or 50 kilometers an hour, during the speed event, and a more energy-efficient 24 knots during the endurance event, equal to 45 kilometers an hour. I can assure you this is crazy fast for a boat. Now, this whole system, the rear strut also acts as a rudder. Therefore, the whole system, including motor, propeller, and driveline, can turn around its axis for the purpose of steering. As Pierre already briefly touched upon, all our components generate a lot of heat, which we need to dissipate in an efficient way. For this, we went looking towards the closest solution. And the solution is actually closer than you think. We cool our components using seawater. For this, we have two small little inlets at the bottom of our front struts. This allows us to pump up and through our boat up to 60 liters of cold seawater, which in turn can cool down the components in our boat. The cold seawater is taken through a series of heat exchangers, which then in turn cool down each and every one of the components of our boat. After passing through these heat exchangers, the cold water leaves the boat at the stern. But propelling, steering, and cooling aren't the only functions our struts have. They also serve another function, a function that will not only give us the edge in both the speed and endurance race, but will also make sure that we have the coolest boat out there in the harbor of Monaco. Won't we?
Oh yeah, it will definitely be the coolest boat out there, trust me. But the last reason why our struts will give us the edge in Monaco has something to do with efficiency, because speed isn't everything in an endurance race. Now, when our boat speeds up, the drag increases with the water, and hence we need more energy to power our boat, and this means that we have less efficiency. Now, to overcome this problem, we place something called hydrofoils underneath our struts. These hydrofoils act in a fairly similar manner as wings on an airplane do. When our boat speeds up, pressure difference occurs between the top and the bottom of the wings. And when this happens, they create an upward lifting force, which pushes on the boat. Now, at 25 kilometers an hour, we reach takeoff speed, and something magical happens. Our entire boat, the 1,350 kilogram boat, the hull, the pilots, the fuel cell, the tanks, everything lifts out of the water. Now imagine this, our entire boat flying above the water, and by doing so, reducing its drag immensely and thus increasing its efficiency. And this way, we are using our 16 kilograms of hydrogen to its fullest potential. But it's not easy to get out of the water, though. So, for that, we have created a specially combined shape for our hull. We combine the shape of a planing hull and a foiling hull. You can hear you ask, what does planing and foiling mean? Well, a planing hull will always want to rise out of the water and glide on top of it, whereas a foiling hull will always want to be above the water. And in essence, this means that we combine the best of both worlds. The planing characteristics of the boat will help it rise up and take off out of the water, and once it's out of the water, the foiling characteristics will help it to stay there, on top of its hydrofoils.
But I can already hear you think, Won't a foiling boat, when it flies up top of its hydrofoils, won't it be inherently more unstable than a non-foiling boat? Won't the waves just push it over?
Oh yeah, those waves will definitely be a problem, especially in the Mediterranean. Because those waves, they cause disruptions on their foils. And these cause disruptions in the lift from the foils, which means that our boat will start to tilt. And we do not want this to happen, so what we have implemented is an active height control system. This height control system uses two sensors aboard, one to measure the orientation of the boat, and one to measure its distance to the water. And it then uses these two inputs to actuate the foils in such a way that our boat always remains smooth. And this way, we will always have a stable flying boat above the waves of Monaco. And trust me, it'll be a sight to behold once it starts flying in Monaco.
Oh, I believe you. And I am so thrilled to, in a few months' time, reveal the finished product with you. So in short, our boat is a very complex thing. It breathes in air, lets it react with hydrogen, does a lot of converting and inverting. It propels itself through the open sea. It needs to cool itself while doing so. And finally, it flies. But let's backtrack for a minute. Why do we do this? Why do we build such a complex machine? Why do we use hydrogen? Because the world is in need of change. The world is in need of new and clean technologies that can compete with the conventional ones. We often hear hydrogen has a huge potential. But hydrogen has more than just a potential. The technologies already exist. And these are ready to be applied in the industry. And that's exactly what we aim to show. By bringing together all kinds of partners. Partners from the maritime industry, partners from the fuel cell industry, partners specializing in high-power electronics, or partners investing in the engineers of tomorrow. By bringing together all these partners, we want to show that change is indeed possible.
We recognize the challenge that the team is working on, and we believe it's a social problem that we all have to deal with. We as company Soltega also contribute to it by helping customers optimizing engineering processes. So in the end, it will reduce waste and lead time of the projects to become more durable. And that's, I think, what we all have to deal with.
We feel that as a bank we have a role to play by the challenges that society faces today. And one of those challenges is climate change. So we really want to put our expertise in raising capital for the energy transition at the forefront of our activities.
As a family-owned company, Damen is always looking out for the next generation and to leave something behind that the next generation can still make use of. That's how we look at our operation and our products. We are always working on how can we do something in the most sustainable way.
We are very much supporting the idea of a group of students building a boat in 1 year, and to realize that all these people are eventually ambassadors of a green and sustainable shipping industry.
For me, it's very inspiring to see that a few students can develop a complete new boat, new ship, within 1 year.
In less than a year, they have to develop a fully operational boat. And on top of that, it's not just a simple boat. No, it's a hydrogen boat.
I think it's very important that this team is a mixed team of all experience. So you have experience on mathematics, you have experience on shipbuilding, you have experience on whatever, and the mix together makes a very good team to develop this type of ships.
It is incredible to me that every year these students are able to interlock all those components and all those different functionalities of the boat into a working boat. It's extraordinary. It can be done in such a short time.
I believe that only through collaboration with all the stakeholders, with the Hydromotion team, all the partners involved, that we'll be able to make this great change through the energy transition.
The cooperation with the TU Delft, Hydromotion, is a clear example of how we can cooperate, because innovation is very important in the way forward.
We are so happy to finally have shared our design with you. It took us long hours, hard work and a lot of cups of coffee to make this design, and we cannot wait to continue with the next phase, making our boat reality. So if you ever wondered what your son or daughter was doing all those long hours in the dream hall, or why your friend didn't text you back for 3 days, this amazing design was the reason. But designing is not the only thing we have been doing. We have been working together, learning together, but most importantly, having fun together. We are much more than just 24 individual students. We are a team. Without the dedication and motivation of each team member, this project would not be possible. I'm truly so proud of this team, so now I would like to put these fantastic team members in the spotlight and welcome them to the stage. In the design of our boat, we combined our own skills, knowledge of partners, experience from alumni, and innovative technologies. In this boat, everything comes together. Together with our team, together with our partners, and together with you. Together, we sail to a sustainable future.
Consequences of climate change are already visible in our daily lives right now.
Producing hydrogen, storing hydrogen, and using hydrogen can all be done with zero waste.
2022 is the year where we, the TU Delft Hydromotion team, will build a hydrogen-powered boat to become world champions in the open sea class of Monaco.
It is our responsibility to make the right choices to positively contribute to the world of tomorrow.
We want to inspire everyone, from individuals to big industry leaders. We want to accelerate the implementation of sustainable energy technologies and work towards a sustainable future.
With that, our design presentation has come to an end. Just like the design phase that comes to an end right before the Christmas holiday. However, we still have a long road to sail before we are ready to win the race in Monaco. 2 weeks ago, we kickstarted production. The phase which will lead us to the next moment that will bring all of us together again. The baptism of our boat in May. Hopefully you will be able to share this moment together. Hopefully in real life. That's something we will see. Unlike the design presentation, this night has not come to an end yet. We've organized an online get-together during which you will be able to ask all of the questions that you may have about our project, our boat, or maybe even our team members. So yeah, for this we have the following breakout rooms that will be shown on the screen right now. Yes, perfect. There it is. Something that's good to know about the quiz. If you would like to attend the quiz, this starts at 2 moments, at 8:30 and at 9 o'clock. So if you want to participate in one of these, be on time for that. We also have a guest book tonight. This will be my teammate Eline, moving around through the different rooms. Her name in Zoom is called Guest Book. So if you would like to say something in the guest book, please send her a private message, such that it can be incorporated in the guest book, which we'll read afterwards, together with the whole team. But the breakout rooms open from now on. So if you have any questions, you can ask them in the appropriate rooms. You can navigate through these rooms with the 4 blocks button. That's also shown on the slide. Personally, I will now go to the partner room. So I hope to see you here back at 9:25 to round off together. Thank you.